The best part about all of this unit circle sinusoidal graph discussion is the word problems. And a lot of times we try to make stuff fit some sort of equation just so we can make a word problem out of it. But anything that spins or sways at a constant speed really does fit a sinusoidal graph, so a sine or a cosine graph, and it fits it perfectly as long as it's spinning at a constant rate. So these are really good problems because of that fact. So what we're going to have here is a Ferris wheel, and our friend Benny is watching it spin around, and he's trying to figure out if he's brave enough to ride it. If it goes over 100 feet, he's going to lose it. So he needs it to be under 100 feet, but he can handle it for 5 seconds. So basically we're going to see when he gets up to the top, over 100 feet, how long is he going to be there? That's the overall question. So usually the way it's going to go is we're going to set up, we're going to have a couple points, a high point and a low point, and we're going to get an equation. We're going to plug in x's and plug in y's to solve for the other. One of those is very easy, one of them is pretty complicated. So let's start with this. What's the equation for the motion of one of these seats? What he saw when he timed it was that 3 feet off the ground was its lowest point, and its highest point was 113 feet off the ground, and that happened 22 seconds later. So the easiest way to do this is going to be to set up just a simple picture. 3 feet is the lowest. I made this 113 so it would have a nice 110 from top to bottom, which makes the amplitude 55. Right between 3 and 113, take that 110, cut it in half to get 55, add it to 3, you get 58. So our sinusoidal axis is at 58. And let's just assume he started the clock, depending on which seat he was measuring, and you could change it, you could shift the graph. But let's just say he starts at time 0 when that seat is at the very bottom. And then 22 seconds later, it's at its highest point. All right, so that means at 44 seconds, it was back down here. This is what I meant about a constant speed. We need this thing to be moving constant speed. Okay, so you have options for the equation. You could do positive cosine, positive sine, negative cosine, negative sine. If we do, notice how on this one, if we do a negative cosine that starts down here at the bottom, then we don't need to do any left or right shift. So that's going to take out one of our variables. So normally an equation, a negative cosine equation, would look like this. And we could do this thing in radians or degrees. It doesn't matter as long as you're consistent all the way through. If we've got, I'm going to do this one in radians. So I'm going to go x minus d. The fact that I start with a negative cosine lets me not have any left or right shift, which means my d value is going to be 0. So from this picture, we need to come up with the equation. This is something you've done. A, remember, is our sinusoidal axis, so that's got to be 58. I'm doing negative b, so because I want this to be a negative cosine. A positive cosine graph starts at the top. And if you wanted to do a positive cosine graph, you could have a 22 shift to the right, and that would be fine there. B is our amplitude, and that's the 55. Okay, now C is the number that when we do 2 pi divided by this number, we get the period of the graph. So it's going to be kind of awkward either way. If it were 360, I would do 360 over 44, which doesn't simplify too well. Since I'm going to do this in radians, just kind of off to the side, C, 2 pi over C gives us the period of the new graph, and that's 44. So it's actually I think a little bit better in radians than degrees. So this means 2 pi over 44 equals C, or pi over 22. So pi over 22 goes here, just working that little process backwards. And x, and again, I don't have any left or right shift because I started at the bottom. at the absolute minimum height. All right, so here's our equation, y in terms of x. What this equation will give us is any time period, and actually I think I asked for t in the question, so let me get rid of that, make that a t. So y in terms of t, it could be x, but t just makes it stand for time a little bit more clearly. How high is a chair 18 seconds after it reaches its lowest point? This is the straightforward plug-in. This is where we just plug in 18. So 58 minus 55 cosine of pi over 22 times 18. And from your graph, you should get an idea 18 will be somewhere in this region up here. So I'm not going to have a perfect value for my graph, but I'm going to have something reasonable. All right, so let's make sure our calculator's in the right mode. It's in radians. That's good. Now I need to do 58 minus 55 cosine of, I'm just going to go 18 pi over 22 to simplify that. 18 pi over 22, and we have 104.3. And we are in, I believe, 104.3 feet. All right, so that makes sense. I mean, it's in the neighborhood, 104, somewhere in that region. All right, so easy way is plugging in a t and getting a y. Now, this next process is where we need to reverse. We need to solve this thing for t so that we can plug in a height and see at what time period are we going to be at this height. All right, so solving this thing for t. I'm going to subtract 58, and I'm going to divide by negative 55 to get it down to just cosine of pi over 22t. You can have parentheses around just the t or around all of that. We're taking the cosine of all of it. Then I'm going to, let me do something just, I don't really like this negative down here. It just bothers me. So I'm going to sort of factor a -1 out of both of those and make that 58 minus y over 55. I didn't have to do that. I just don't really like that negative being there. Then my next step was going to be to inverse cosine it. And then to get, at that point, I'm at pi over 22t, and so I need to multiply by 22 over pi. And this is something we've done in a prior section. So here it is solved for t. All right, just undid all those steps that had happened to t. Subtract 58, divide by -55, inverse cosine, and multiply by 22 over pi. Now, how long will the chair be over 100 feet? So at some point here, up at the top of this motion, whenever we get to 100, the question is, how many seconds is that going to happen? So what we need to do is figure out what values are going to make this equal to 100. So I'm going to substitute in 100 for y. So it's going to look like this. 22 over pi times the inverse cosine of 58 minus 100 over 55. And then I need to get some t values. All right, so let's see, 58 minus 100 over 55 is this number, -0.7636. I'll use that specific number in my calculator without erasing it so I can have a more precise answer. So now I need to inverse cosine that number, inverse cosine of my answer. So I'm telling my calculator, this is the cosine, you give me the arc measurements. I would say give me the angle, but we are in radians. So if you're okay with angle in radians, then that's what we have let's call this 2.44 radians. 2.44 radians Now, think about what you're telling your calculator. You're saying, calculator, tell me when my x value is negative 0.76. So here's our unit circle. Here's negative 0.76 in the x direction. And the calculator gave you 2.44, which is here. That's, think about it, the top of the circle is pi, which would be 3.14, so we're not all the way to 1 pi. So your options with cosine, you can always do plus or minus. So I'm going to do that on this one. This is negative 2.44. All right, so 2.44 plus 2 pi n, because remember, we need to allow to all possible values. It's just going to, I'm going to be able to use the first two positive values on this particular example, but you might not always be able to, so we'll just get them all. Or this is where I need to split into two parts. 22 over pi times negative 2.44 plus 2 pi n. Okay? And a couple of different ways you can approach it from here. I'm going to distribute this 22 over pi. 2.44 times 22. I'm going to keep my 2.44 number, again, to use it, to keep it more specific. I'm going to multiply it by 22. Get 53.674 over pi. I didn't involve the pi yet. Plus, now I'm multiplying 22 over pi, I'm just distributing here, by 2 pi n. So the pi's cancel. 2 times 22 is 44 n. And this one, this is just the negative of that one, so this is negative 53.674 over pi. You could go ahead and divide that number by pi and incorporate that into the decimal if you want to. But either way is fine. So what I need to do is find two consecutive values where this is true. So this one, I'm going to take my 53.674 divided by pi and see what I get. Divide that by pi, and I get 17.08 plus 44n. So if n is 0, this is 17.08. If we look at our picture, 17.08, this is 100, that's right here, 17.08. So that's the first time on the way up that I passed 100 feet. I don't want to, I want to have a decent picture. It doesn't have to be perfect, but you should get an idea of whether your answers are right from your picture. My other number then, over here, this one was negative, by the way, if I add 44 to this one, for n equals 1, 1708 plus 44, should be able to do that and make sure is 61.08. And that is, that would be happening over here, the next time up. All right, the other equation is going to produce this value, which is the time period, or the time when I cross back under 100 feet, and Benny can stop freaking out. That should happen over here. Let's get, oh, we're dealing with the same number. So when n equals 0 over here, I have negative 17.08. When n equals 1 here, I have negative 1708 plus 44, negative 17.08 plus 44, and that one is 26.92. And that happens right here. This value right here, 26.92, that's when we cross back under 100 feet. All right, so I am over 100 feet between 17.08 seconds and 26.92 seconds, which is 26.92 minus 17.08, 9.84 seconds is the time which the height of this spinning wheel will be up above 100 feet. So if Benny can only last at that height for 5 seconds, he is not going to enjoy this ride. He's going to be up there for almost 10 seconds. Um, we could also have, well, I'll leave that for another day. All right, so this is one good, solid sinusoidal model problem. The important parts are to come up with the equation based on a sketch, plug in x values, in this case t values, but that's easy. Be able to solve it for x, or in this case t, and use that fact to find certain times when y values happen. All right, so that is it for this one. Young out.